In 2011, while you were probably thinking about something else, IBM's Watson defeated the two greatest Jeopardy champions in the history of the show, Ken Jennings and Brad Rutter, simultaneously across 74 questions spanning trivia, wordplay, cultural references, and abstract reasoning. Ken Jennings, in his final response, wrote, "I, for one, welcome our new computer overlords." He meant it as a joke. It was also not entirely a joke. In 2012, while you were definitely thinking about something else, a team at Google Brain led by researcher Andrew Ng and Jeff Dean built a neural network that, without being told what a cat was, taught itself to recognize cats by watching 10 million unlabeled YouTube thumbnails. The network spontaneously developed an internal representation of cat from raw visual data alone. This was not a party trick. This was the moment that demonstrated a principle that would reshape everything. Given enough data and enough compute, these systems could learn representations of the world that no human had explicitly programmed. They could develop their own categories, their own abstractions, their own internal models of reality. In 2016, while the world was focused elsewhere, a system called AlphaGo, built by DeepMind, a research lab owned by Alphabet, Google's parent company, defeated Lee Sedol, the world's greatest Go player, 4-1. This matters more than it might seem. Go is not chess. Chess has approximately 10 to the power of 47 possible game states. Go has approximately 10 to the power of 170, a number so large that it exceeds the number of atoms in the observable universe. No amount of brute force calculation can navigate that space. To play Go at the highest level, you need something that looks, from the outside, disturbingly like intuition. AlphaGo had it. In Game 2 of that match, AlphaGo played what commentators and Go masters watching the match described as a move that no human player would ever have played, not because it was wrong, but because it was so unexpected, so outside the established vocabulary of the game that human players had simply never considered it. Move 37. A move that the AI had calculated gave it a slightly higher probability of winning, through a chain of reasoning too long and too non-linear for any human mind to trace. Researcher Demis Hassabis, the founder of DeepMind, described AlphaGo not as a system that had learned to play Go, but as a system that had developed its own understanding of Go, an understanding that in some respects exceeded the accumulated wisdom of 3,000 years of human mastery. 3,000 years, exceeded, quietly, while you were not looking. But here is the part of the story that gets least attention. The part that matters most for understanding where we are right now. While AlphaGo was making headlines, something more significant was happening in the background. AlphaGo had been trained on millions of human Go games. It had learned from human expertise, absorbed human patterns, and then surpassed them. Its successor, AlphaGo Zero, was given no human games at all. It was given only the rules of Go and told to play against itself. Starting from nothing. No human knowledge. No centuries of accumulated strategy, just the rules and time. In 3 days, AlphaGo Zero reached the level of the original AlphaGo. In 40 days, it had surpassed every human player who had ever lived. Its playing style was described by researchers as fundamentally alien, not worse than human, not merely better, but categorically different. It had invented strategies that human players had never conceived of, in domains of the game that human players had never fully explored, because human intuition had never pointed in those directions. It had not learned from humanity. It had learned past humanity. This transition, from AI that learns from human knowledge to AI that generates knowledge humans have never had, is the most important thing that happened while you were not looking. In 2020, while a global pandemic occupied essentially all of human attention, an AI system called AlphaFold, also built by DeepMind, solved a problem that had stumped the biological sciences for 50 years, the protein folding problem. Every living cell in your body manufactures proteins based on genetic instructions. The shape of a protein determines its function, and the relationship between a protein's genetic sequence and its three-dimensional shape is so complex, so dependent on an astronomical number of interacting variables, that predicting it had defeated the best scientific minds and the most powerful computers for half a century. AlphaFold solved it. Not approximately, not partially. It predicted protein structures with accuracy that matched or exceeded experimental results obtained through decades of painstaking laboratory work. In a single system, released openly, for free, to the global scientific community. Researcher John Molt, who had organized the international competition for protein structure prediction for 30 years, described AlphaFold's performance as a stunning advance that represented, in some sense, a solution to one of biology's grand challenges. In some sense, in every sense. And most people, in 2020, did not know it had happened. So what was AI doing while you were not looking? It was learning to see. In 2015, Google's image recognition AI surpassed human performance on the ImageNet benchmark, the standard test for visual object recognition. For the first time, it was learning to hear. Speech recognition systems crossed the human parity threshold around 2017, achieving error rates lower than professional human transcriptionists. It was learning to read. Language models grew from systems that could barely form coherent sentences to systems that could pass the bar exam, write working code, and compose prose indistinguishable from human writing across a span of roughly 5 years. It was learning to discover. AI systems began identifying new materials, new drug candidates, new mathematical theorems, not by executing human instructions, but by exploring possibility spaces so vast that no human research program could have traversed them. And it was learning to learn. The most profound development of the last decade in AI research is not any specific capability. It is the emergence of systems that can improve their own learning processes, that can, given a new task, figure out how to figure it out, without being explicitly programmed for that task. Here is the counterintuitive part. None of this is a reason for fear. Or rather, fear is not the most useful response. The most useful response is the one that has always served humanity best when confronted with transformative technology. Understanding. Researcher Stuart Russell at UC Berkeley, one of the world's leading AI safety researchers and co-author of the definitive textbook on artificial intelligence, has argued for decades that the primary risk of advanced AI is not malevolence, machines that want to harm us, but misalignment. Systems that are extraordinarily capable of pursuing the objectives they are given, but have been given objectives that do not fully capture what we actually want. In plain English, the danger is not that AI will decide to work against us. The danger is that we will not be precise enough about what we ask it to work toward, which means the most important thing you can do, more important than any specific technical skill, more important than any particular AI tool, is develop a clear, sophisticated understanding of what these systems actually are, how they actually learn, what they can and cannot do, what happens when you give them imprecise instructions, and what it means to use them as an extension of human intelligence rather than a replacement for it. This is what organizations like Pinnacle AI Solutions are built to provide, not just access to AI tools, but the strategic intelligence to understand what those tools are actually doing, at a level of depth that the vast majority of people who use them every day have never developed. You were not paying attention, but now you know what happened while you were not. A non-biological system spent 66 years learning to think. It defeated the world chess champion. It defeated the world Go champion with a move no human had ever conceived. It solved a 50-year-old biological mystery during a global pandemic. It learned to see, to hear, to read, to discover, and to learn, faster, and in some domains more deeply than the 3 billion years of biological evolution that produced the brain you are using right now to understand this sentence. And now it is here, in your phone, in your search engine, in your newsfeed, in the tools you use at work, in the systems that decide what you see, what you buy, who you meet, what you believe. The question is no longer what AI was doing while you were not looking. The question is what you are going to do now that you are.